In this video, we focus on translating hyperbolas vertically and horizontally. Now, if we translate hyperbolas vertically, it changes the value of q. And like with all functions, if I want to move the graph up, I add to q, and if I want to shift the graph down, I subtract from q. So let's look at a specific graph. Here I have the hyperbola y equals 6 over x minus 1 plus 2. Now, if I wanted to shift this graph 2 units up, I am going to add 2 to the q. But before we find the equation, let's draw this shifted graph. Okay, so to shift the graph, every point shifts up by 2 units. Now, I'm not going to accurately calculate every point, but I will just highlight some points. So 3, 5 will go to 3, 7. Okay, so then I'm just going to draw a rough sketch. It won't be accurate, but just remember every point should move up by 2 units. Okay, then the horizontal asymptote shifts up. Okay, so it goes from y equals 2 to y equals 4. My vertical asymptote, however, doesn't change. Okay. Right, if I look at the point negative 2, 0, that will go to negative 2, 2. So if I'm shifting vertically only, notice that the x values don't change, and that is why the vertical asymptote doesn't change. But what does change is the y coordinates increase if I'm shifting up. Okay, if I'm shifting down, they obviously decrease. Okay, so again, a rough sketch of the arm there and respecting the vertical asymptote there. So this red graph is our original graph shifted up by 2 units. Now, you would have to be able to give the equation of this you'd have to give the equation of the shifted graph. So what this would look like is you start with the original equation, which is 6 over x minus 1 plus 2, and shifting it up by 2, you add 2 to the q value, okay? And then you simplify. So it ends up being 6 over x minus 1 plus 4, and that is your final answer. Okay, now if we wanted to shift the original graph, okay, 3 units down. Okay, let's look at the actual graph. So looking at the original graph here, okay, so this will start to look quite confusing. So I'm going to make a very fat graph for our new graph. So I'm going to shift the points down by 3 units. Okay, so starting with the 3, 5, shifting that point down 1, 2, 3, it will go to 3, 2. Okay, if I shift the point negative 2, 0 down 3 units, it will go to 1, 2, 3, negative 2, negative 3. Again, the vertical asymptote doesn't change, and neither do any of the x coordinates. Okay, now what it does change is the horizontal asymptote, so it will also shift down 3 units. So it will go from y equals 2 to y equals negative 1, having subtracted 3 from 2 there. Okay, and then I can draw the graph. Sorry. Okay, so to find the equation then, if I'm shifting down, I will subtract from q. So I have 6 over x minus 1 plus 2 as my original, and then I'm shifting 3 units down, so I'm going to subtract 3 from q, and I'm left with 6 over x minus 1 minus 1 as my final equation there. Right, let's look at translating hyperbolas horizontally. Okay, so when I shift horizontally, it affects the value of p. So changes the value of P. Okay. Right. Looking at a specific example, we have the same graph, y equals 6 over x minus 1 plus 2. Okay. If I wanted to shift this graph 2 units left, okay, let's start with the equation now. If I'm shifting left, it means that I'm going to be adding a value to x in the denominator. Okay, so I have my original graph, y equals 6 over x minus 1 plus 2. Now, to calculate or to account for the shifting 2 units left, I'm going to add 2 to x in the denominator. So now I can simplify that, and I'm left with 6 over x minus 1 plus 2, which is x plus 1 plus 2. Okay, now I just want to say an easy way to check whether you've done the horizontal shift correctly is to look at the vertical asymptotes. The vertical asymptote of the original graph, we calculate using the denominator. So I take the denominator, make it equal to 0, and then solve for x. So it's x equals 1 is the original vertical asymptote. The new vertical asymptote, after having shifted the graph 2 units left, is I take the denominator x plus 1, make it equal to 0, solve for x, I get x equals negative 1. And notice that from 1 to negative 1 is a movement of 2 units left, so it is correct. Now let's draw this graph. So I take the point 3,5, if I'm going to shift it 2 units left, it'll go to the point 1, 5. Notice the y coordinate stays the same, the x coordinates change though. Okay, looking at the vertical asymptote, it goes from x equals 1, shifting it across 2 places, it'll go to x equals negative 1. Looking at the point negative 2, 0, moving it to the left by 2 units, it'll go to negative 4, 0. Okay, and if I draw a rough sketch, there we have the one arm and the other arm sits there. Okay, so what about shifting right? So let's shift the original graph 3 units right. Okay, again, this will affect the p-value. Okay, now if I'm shifting right, I need to subtract from the x in the denominator. Okay, so looking at the equation first again, I start off with the original, 6 over x minus 1 plus 2. And if I'm moving right, I'm going to subtract from the x in the denominator however many units I'm shifting by. So that's 3. Okay, simplifying this, I'm left with 6 over x minus 4 plus 2. Okay, again, let's just check with the vertical asymptote. I take the denominator, make it equal to 0, solve for x, and it's 4. So from x equals from x equals 1 to x equals 4 is a shift of 3 units to the right. Okay, so let's draw this graph, and let me make it a fat graph. Okay, so the point 3,5 shifted 3 units right will go to 1, 2, 3, 6, 5. Okay, and the point negative 2, 0 shifted 3 units right will go to 1, 2, 3, 1, 0. The vertical asymptote, which is sitting at x equals 1, will shift to 1, 2, 3, x equals 4. Okay, and then roughly sketching this graph, so it's the one arm is there and the other is there. Okay. Now we're just going to quickly run through 2 more examples of finding the equation, just to make sure that you get it. Okay, so the first one says, consider f of x equals 2 over x minus 2 plus 3. Give the equation of the translated function if f of x is shifted 4 units to the right and 5 units down. So let's call our new function g of x. Okay, now I'm going to write f of x as it originally is with some space to add and subtract. Okay, now shifting 4 units to the right, when I move to the right, I subtract. So I'm going to subtract 4 units in the denominator. When I shift down 5 units, I'm going to be subtracting 5 from q. Okay, so now we can simplify this, and we are left with 2 over x minus 6 minus 2. If you want to check the horizontal shift, look at the vertical asymptotes. So I have x minus 2 equals 0, gives me a vertical asymptote equation of x equals 2. For this graph, x minus 6 equals 0. Solving for x, I have x equals 6. So from 2 to 6, I'm shifting 4 units right. It is correct. Okay, second example. Consider f of x equals negative 4 over x plus 1 minus 3. Give the equation of g of x. F of x shifted 4 units to the left and 9 units up. So my new graph is g of x. I'm going to write the original f of x. Okay, and then I'm going to add and subtract as needed. So it says 4 units to the left. When I shift left, I'm going to add to x in the denominator. So I'm going to add 4 units. If I'm shifting 9 units up, when I go up, I add those units to q. So simplifying this, I'm left with negative 4 over x plus 5 plus 6. Again, let's check the asymptotes. X plus 1 equals 0, solve for x. So I have a vertical asymptote of x equals 1. This vertical asymptote is x equals negative 5. Okay, so from negative 1 to negative 5, I have shifted 4 units to the left. So this is correct.